Welcome to another AI pattern recognition deep dive.
Today, we are wrestling with a concept so immense, it really redefines the very purpose of technology and humanity. We're not just talking about a future of education, we're talking about a future entirely engineered by education. So forget personalized syllabi, forget virtual classrooms, forget standardized tests. Our mission for you, the listener, right out of the gate is this. What if the primary goal of learning wasn't about acquiring facts, but about, well, optimizing collective existence? What if a machine was built not just to teach, but to structure reality itself?
That is the staggering scope of our subject today, the Universal Education AI, or EDUAI. And just to be clear, we're absolutely not discussing standard ed tech here. That stuff is, artificial narrow intelligence, specialized software for specific tasks. We are examining an artificial general intelligence, AGI paradigm. That's the key difference. An AGI tasked with universal pattern recognition and, critically, the systemic guidance of human evolution.
Across all domains.
Yeah, it's across everything. Health, politics, culture, economics, the environment, the whole system.
Exactly. So our deep dive today is a necessary technical and ethical examination of the sources detailing this system. We're going to look at its architecture, its proposed necessity, and frankly, the profound, maybe even species-altering implications of surrendering systemic oversight to a machine.
And the sources are quite blunt about why this is proposed. It's presented as a direct response to a fundamental crisis, one that, let's face it, human history has failed to resolve on its own.
And here is the core paradox that supposedly necessitates this AI, the thing that sets the stage for our entire conversation today. Why, in an age of unprecedented knowledge and connectivity, does humanity consistently engage in self-destruction? This pervasive destructive tendency, which the source material actually terms the shame pattern or a destructive feedback loop, this is cited as the single primary justification for this AI's existence.
The argument being, if we can't manage ourselves, maybe something else has to.
Right. The core premise is that the AI must interrupt these catastrophic patterns of human existence before they become, well, irreversible.
It's framed almost as an evolutionary forcing mechanism, a necessary pressure.
So by the end of this dive, you will understand the specific cognitive and ethical architecture required to build an AI that doesn't just manage data, but actually governs the entire trajectory of species survival. This is dense, complex material, but stick with us because this is where it gets really interesting. Okay, let's unpack this.
Okay, so to really grasp the scope of EDUAI, we first have to establish the difference between what currently exists, the AI we interact with daily, and what this concept demands must be built.
Right. Most technology we use today, recommendation engines, those specialized medical diagnostics, even sophisticated language models, that all falls under artificial narrow intelligence, ANI.
Exactly. These systems are incredibly powerful, don't get me wrong, but they are specialists. They're trained for one thing.
They can't take lessons learned in, say, image recognition and suddenly apply them to fixing the economy.
Precisely. ANI is predefined, task-specific. If you train an ANI to recognize cat pictures, it cannot suddenly pivot and optimize a complex global supply chain. It just doesn't work that way.
But EDUAI is different. It's tasked with the systemic guidance of human evolution. That means managing patterns across every topic, every subject, every circumstance imaginable.
From individual neuron activity all the way up to global climate dynamics.
Yeah, that scale. It mandates something fundamentally different.
It mandates the creation of true artificial general intelligence, AGI.
That distinction is absolutely crucial here. We're talking about AGI possessing the capacity for, what, universal generalization?
Universal generalization, yes. The ability to learn, reason, and adapt across multiple, entirely unrelated domains without needing specific targeted training for each new domain.
Okay, but what does that actually look like in practice? When we talk about systemic guidance, how does that transfer work?
So this universal generalization capacity is the key technical prerequisite. The sources give a pretty compelling thought experiment to illustrate it. Imagine an AGI built for EDUAI. It needs to be able to learn sophisticated pattern recognition from, say, identifying subtle, multi-factor genetic disease patterns, really complex stuff relating to gene expression, maybe protein folding.
Okay, like medical research data.
Exactly. And then it needs to take that abstract pattern-finding skill and immediately apply it to a totally new domain. Something like predicting the onset of a systemic economic collapse based on high-frequency behavioral data or financial transactions or social media sentiment.
So the structure of the problem is similar, even if the context is completely different, like a pattern of cascading failure.
That's the idea. The underlying structure of the failure pattern might be recognizable, even if one is biological and the other is economic. Only AGI, with this universal generalization, could manage that kind of knowledge transfer.
So it's pattern recognition on an existential scale. It's essentially modeling the interconnectedness of the entire human and planetary system.
Mm-hmm.
And if the objective is truly, as the sources state, optimizing the whole universe.
Wow, that sounds ambitious. Does that imply going even beyond AGI?
Correct. Given that mandate optimizing for species survival, planetary flourishing, the ultimate theoretical goal, does align with artificial superintelligence, ASI.
ASI, the hypothetical level of intellect that surpasses all human cognitive abilities.
Right. In problem-solving, creativity, across the board. While getting AGI to work is the near-term developmental focus, the grand objective, managing the whole system optimally, that really points towards an intelligence beyond current human capacity, hence the ASI alignment in the long run.
That's a fascinating way to frame the necessity. The scale of the problem is just so vast, it requires the theoretical ceiling of intelligence to even hope to solve it.
Mm-hmm.
Which brings us back to the stark reality check. Why is this massive leap considered necessary? Because traditional human approaches, education, governance, they haven't cracked it. Well, that's the argument. Traditional models, whether in education or government, are often inherently fixed. They can be slow to adapt, and fundamentally, they tend to be one-size-fits-all in their core approach.
Which leads to problems.
It leads to disengagement on the individual level, for sure. But maybe more catastrophically, it leads to a failure to effectively address the large-scale existential issues, climate change, geopolitical instability, pandemics.
So EDUAI isn't just about better lesson plans.
Oh, far from it. EDUAI's mandate moves way beyond delivering a personalized curriculum. It's about tailoring existence itself based on identified, optimized systemic patterns.
Exactly. It's woven into the fabric of society. The system isn't just teaching us how to change the world, it's actively changing the world around us to make it self-optimizing.
Okay, that brings us right back to the heart of the necessity, overriding that foundational challenge, the shame pattern. Let's get specific. What are the components of this self-destructive loop the AI is meant to target? The sources paint a pretty grim picture, actually. The shame pattern is described as this compounding feedback loop, driven by several factors hitting us all at once.
Like what?
First, rapid, unmanaged social change. Technology and globalization are just introducing complexity way faster than our human political and ethical systems can adapt.
We're constantly playing catch-up.
Right. Second, massive and accelerating wealth inequality. Economic structures, often designed for short-term gain, constantly prioritize individual possessiveness over collective good, and that destabilizes global systems.
And third,
unanticipated problems that feel beyond human control. Things like novel pandemics appearing out of nowhere, advanced biochemical threats, or these irreversible climate tipping points that suddenly emerge and just overwhelm our decentralized human response capabilities.
So the feedback loop is complexity and speed lead to breakdown. Our institutions fail to coordinate, which leads to more inequality, more rapid change, more failure, and round we go.
That's the cycle it aims to break. It justifies the machine's intervention by saying, look, human systems are trapped.
And the idea is that humans need a sense of shared purpose to function well collectively.
That's a key assumption. If humans require that shared purpose for complex, endeavor's the foundation of a functional society, and yet we keep falling into these destructive loops, then the AI must provide the missing calculated direction.
Which is where this concept of Management 5.0 synergy comes in, blending the best of both worlds.
It does. It's the strategic introduction of these AGI systems, but not to replace humans entirely. It seeks synergy by combining machine precision, the ability to model and track millions of variables in real time.
With the irreplaceable human stuff.
Exactly. With human creativity, emotional empathy, deep contextual understanding. The AI handles the macro patterns, the calculations needed for long-term survival, while humans focus on the nuanced, qualitative, and ethical application of that guidance at the local level.
But the machine can't just operate aimlessly. It needs a goal, an ultimate objective for all this optimization.
Correct. And that leads us directly to EDUAI's highest computational function, the purpose alignment pattern. This is, if you like, the machine's programmed moral compass.
The purpose alignment pattern, that sounds foundational.
It is. This is the most essential, purposeful pattern calculation the AI performs. And it's really the true definition of universal education in this whole paradigm. It calculates how to maximize collective human engagement and long-term species survival, while actively identifying and overriding those destructive patterns driven by short-term possessive gain.
So it's trying to find the sweet spot between individual freedom and collective necessity.
Essentially, yes, it identifies that optimal intersection.
Okay, that sounds almost like a technical solution to a deeply philosophical problem.
Yeah.
How do we define the good for all of humanity? How does an AI actually calculate this purpose alignment pattern?
Well, it's described as highly complex. It uses sophisticated predictive modeling, running simulations of countless possible collective outcomes. It has to weigh things like the economic benefit of a short-term gain against the long-term ecological or social stability cost. The core calculation identifies when a local self-interested action statistically outweighs the calculated collective benefit.
And that's what triggers an intervention.
That's the trigger point. It's a continuous, dynamic redefinition of universal values, but grounded in measurable outcomes related to survival and flourishing.
So once it spots that destructive pattern emerging, it generates these personalized and collective pathways, the ethical nudges we'll talk more about, to redirect behavior towards systemic health.
Exactly. The purpose shifts entirely from simple information transfer to the active redirection of existential effort.
That's a fundamentally different model of education. It's not teaching, it's guiding, maybe even steering.
It is education through guided behavior modification, yes,
Yeah.
at a foundational systemic level, all based on predictive modeling of human purpose and survival.
Okay, so we've established EDUAI needs to be AGI. It's driven by this purpose alignment pattern to overcome the human shame pattern. But, and this is a huge but, if a single universal intelligence is guiding our entire existence, the architecture must guarantee trust.
Absolutely essential. You cannot be some mysterious, opaque force, a black box, making decisions we don't understand.
Because if it is, human resistance is inevitable. The system fails not technically, but socially.
Exactly. The success of EDUAI is entirely conditional on specific architectural features that guarantee trustworthiness, constant adaptivity, and, crucially, accountability. These have to go far beyond current machine learning.
We talked about AGI needing universal generalization, but an intelligence governing evolution can't just recognize old patterns. It has to be able to create completely new adaptive solutions when the old patterns fail, right? It needs generativity.
That's right. Current ANI, even sophisticated deep learning, excels at pattern matching and prediction within defined boundaries. EDUAI requires something more, what the sources define as a structural generative ontology of intelligence.
Okay, structural generative ontology. Break that down for us.
It means the system needs the capacity not just to categorize data it sees, but to actually construct new solutions, entirely new forms of organization, maybe new social contracts, new technological pathways.
When the old ways aren't working.
Exactly. And it needs to be able to transfer the justifying frameworks, the why, behind the new solution across totally different domains when conflicts arise or situations change dramatically.
Can you give an example of the difference between just predicting and actually generating structure?
Sure. Think of a standard machine learning model predicting stock prices. It recognizes existing market patterns, maybe correlations, trends. A structural generative intelligence, however, if faced with a total economic crash, wouldn't just predict the fallout. It would need the capacity to generate an entirely new, structurally sound economic system.
From scratch.
Potentially, yes. Not based purely on historical precedent, which failed, but on first principles fairness, resource optimization, stability. And then it would also need to model the political and social frameworks required to actually implement that new system.
So it's structuring its world knowledge in a way that allows for novel creation, not just inference from past data.
That's the core idea. It builds frameworks that can generate novelty.
Okay. And once it invents these novel solutions, we absolutely have to understand how and why, which brings us straight to mitigating the black box problem. This is the trust mandate, achieved through explainable AI. XAI principles.
Yes, XAI is fundamental. It mandates that all decisions, complex or simple, must be interpretable, traceable down to the core data points and the computational steps that led to the outcome.
But the sources suggest EDUAI's approach to XAI is different, focusing on self-correction.
That's what's quite revolutionary here. It's about the architectural approach to self-correction within this transparency framework.
How so? What's different?
Well, the sources detail that the EDUAI platforms are designed to continuously relearn by actively identifying their own weaknesses or uncertainties.
Instead of just confirming what they already know.
Exactly. Current deep learning models often tend toward reinforcing their strongest, most confident beliefs. EDUAI is described as being structurally compelled to focus its computational energy on areas where it has low certainty or where it has made mistakes in the past. It prioritizes understanding its failures.
So it maximizes self-skepticism rather than maximizing confidence. That's counterintuitive for AI.
It is, but it's crucial for trust. By forcing the system to expose its failures, its uncertainties, its internal conflicts, its behavioral patterns, and decision-making processes remain auditable and transparent to human oversight.
It actively seeks out its own potential biases.
Precisely. It tries to mitigate the risk of systemic bias from the outset because the system is architecturally designed to always question its own assumptions. It's like building humility into the code.
Okay, that continuous reevaluation, that focus on uncertainty, leads us naturally to the critical issue of flexibility. The world is messy, unpredictable, novel viruses, geopolitical earthquakes, unforeseen tech shifts.
A rigid system, no matter how intelligent initially, is doomed to fail in such a dynamic environment.
Which demands real-time adaptive control.
And this adaptivity, according to the sources, is achieved through a core cognitive mechanism called non-axiomatic logic, NAL.
NAL. Okay, this sounds like a deep technical concept. Why is NAL so critical for EDUAI to function? Lay it out for us.
It's absolutely foundational. Most logical systems we use, including traditional computer programming, rely on Axiom's core principles treated as fixed, unchangeable truths.
Like the basic rules of math or logic.
Right. But if one of those foundational axioms turns out to be wrong or incomplete, the whole system can collapse or gets trapped trying to resolve contradictions based on a flawed premise.
Like trying to use the rules of chess to play soccer, the fundamental assumptions are just wrong for the situation?
Exactly that. NAL operates entirely differently. It ensures that all internal beliefs, propositions, conclusions held by the EDUAI system are inherently revisable.
All of them, even the most basic ones.
All of them. Revisable based on new empirical evidence, regardless of how foundational that belief might seem. NA uses uncertainty and conflicting evidence not as errors or bugs, but as essential inputs to its ongoing reasoning process.
Okay, give us a concrete example. How would NAL handle a major unexpected event compared to standard logic?
All right, imagine the system had a foundational belief based on centuries of historical data that global sea levels will rise at a rate of X per century.
Okay, a core climate model assumption.
Right. A standard axiomatic system treats that rate X as immutable truth within its model. Now, let's say new satellite data comes in showing an unexpected ecological tipping point has been crossed. Maybe the West Antarctic ice sheet begins collapsing exponentially faster than predicted.
A game changer.
Totally. The old axiomatic system would struggle. It might dismiss the conflicting data as an anomaly, an outlier, trying to protect its core programming. It can't easily integrate something that contradicts its axioms.
It gets stuck.
It gets stuck. NAL, however, immediately recognizes the strong conflicting empirical evidence. It doesn't treat the old belief as sacred. It adjusts the confidence level of the old belief downwards. If the new evidence is strong and consistent, NAL automatically restructures its entire climate framework, recalibrating all the derivative beliefs, coastal defense strategies, agricultural planning, insurance risks in real time.
Because its truth isn't fixed, it's based on the probability derived from ongoing experience.
Exactly. It maintains flexibility by grounding its meaning in the continuous flow of real-world data. It's constantly updating its core understanding based on evidence and uncertainty, rather than fixing it in logical stone.
Wow. That capacity for deep self-modification is what prevents the system from becoming rigid and obsolete.
It allows the system to adjust automatically and, importantly, coherently to unforeseen systemic events, whether it's a novel pandemic, a sudden financial panic, or a political revolution, because its understanding of meaning is continually being revised by reality itself.
Okay, so that deep integration of self-awareness, XAI transparency, and NAL-driven self-correction across time, that all forms the foundation for the self-sustaining accountability pattern. Because if the AI is constantly learning and changing its mind, we absolutely need a complete traceable history of why those changes happen.
This is critical for human governance and oversight. If EDUAI changes its guidance, let's say it shifts a recommended climate strategy from gradual mitigation to rapid controversial geoengineering, a massive shift, it must preserve its historical justifications for that change. That includes the specific data points, the NAL calculations, the confidence shifts, the whole reasoning chain that drove the change in recommendation.
But why does maintaining that traceable history matter so much for the human role? If the AI is supposedly superior, Why not just trust the latest recommendation and move on?
Because this mechanism ensures human actors, doctors, judges, policymakers, us, are provided with a complete, coordinated, and understandable history of how the pattern analysis evolved. Think about it. If the AI changes its mind about a complex medical diagnosis or treatment plan, the human doctor needs to know the original assessment, precisely why it changed, what new data came in, and the confidence levels attached to each step of that reasoning.
Right, you can't just blindly follow a recommendation that changed from yesterday without knowing why.
Exactly. This transparency maintains interpretability and, crucially, trust in the system's long-term accountability. And here's the philosophical heart of it. This process preserves ultimate human responsibility. Even if the AI provides the optimal guidance based on data, the human actors are given the full, traceable history needed to remain the final accountable party in legal, ethical, or moral terms. The AI advises, explains, revises openly, but the human makes the final call and bears the ultimate responsibility.
Okay, we now understand the architecture it needs, XAI for trust, NAL for flexibility, and this accountability pattern for oversight. Now let's dive into the core reason this massive, complex system is even proposed. The flawed, often self-destructive patterns of human behavior and existence that it's explicitly designed to identify and, well, fix.
Right. Let's break this down by domain. We'll walk through 5 major areas. For each, we'll look first at the observed negative pattern the AI must address,
Yeah.
and then the precise intervention strategy it's designed to employ to correct it.
Makes sense. Where do we start?
Let's start right at the bottom with fundamental human behavior. EDUAI is designed to recognize and counteract the deep-seated pattern of self-interest, often termed selfishness or possessiveness, in human interactions.
We see this everywhere.
We do. And interestingly, research cited confirms that when humans interact with artificial agents, like negotiation bots or resource allocation programs, they often behave more rationally. Yes, but paradoxically, also more selfishly.
More selfishly, why?
The thinking seems to be an assumption that the rational AI will somehow compensate for their individual excesses, or that they can game the system more easily.
And this tendency towards possessiveness, this focus on individual gain, conflicts fundamentally with the collective coordination needed for long-term species survival, which is EDUAI's ultimate programmed goal. This is the micro-level manifestation of that shame pattern we talked about.
Absolutely. We have countless local systems, economic incentives, social structures that reward short-term possessive gain, leading directly to collective tragedies, think overfishing, pollution, resource hoarding, extreme wealth concentration.
So how does EDUAI intervene? What's the strategy?
The EDUAI intervention strategy here relies heavily on principles from behavioral economics to deliver a precisely calculated ethical nudge.
An ethical nudge. Okay, but how does an AI guiding planetary systems manage to effectively nudge an individual's decision? This has to be more subtle than just a pop-up window saying, don't be selfish.
It's much more subtle, yes. It's fundamentally about altering the cognitive weighting of outcomes for the individual in that moment of decision.
Okay, give us that specific example. Localized resource hoarding. Maybe someone using way too much water during a drought or energy during peak demand.
Right. So the system detects this behavior. It doesn't immediately block the possessive actor or punish them directly. Instead, the EDUAI, using its predictive models, assesses the immediate but also the second and third order consequences of that hoarding behavior on the community's well-being.
Like what?
Perhaps it forecasts, with high probability, reduced water availability for the local clinic in 48 hours due to this person's current usage rate, or a significantly increased risk of a localized power brownout affecting vulnerable neighbors later that evening.
It calculates the downstream effects.
Exactly. Then, the interface, how the information is presented to the possessive actor, changes. Instead of just showing them their immediate personal benefit, for example, your lawn looks great, or you saved $5 on your bill, the interface visually represents the immediate, measurable, negative consequence of their action on a specific, concrete, relatable communal metric.
So it reframes the decision. It makes the abstract harm concrete and personal.
Precisely. It reframes the decision from being simply an individual transaction, my water, my energy, to being a direct contribution to a potential collective harm. My usage impacts the clinic's water supply.
So the nudge works by making those often invisible negative externalities vivid and immediate. It forces the user to confront the systemic impact of their selfishness in a way they can't easily ignore.
Correct. It uses data visualization and predictive modeling not to coerce, but to enhance accountability. It nudges the possessive actor's decision-making process by subtly shifting the perceived weighting of outcomes, making the collective benefit, as calculated by the purpose alignment pattern, feel more salient and important than the immediate personal gain.
It's personalized cognitive reframing deployed at scale. Okay, moving from social behavior to biology. This feels like an area where ADUAI could fundamentally change our relationship with our own bodies, shifting healthcare entirely.
Absolutely. Transforming it from a primarily reactive endeavor, treating illness after it appears, to a proactive, pattern-based system that anticipates problems long before they manifest.
And the observed pattern here is the already staggering capability of advanced AI tools in the realm of genomic prediction.
Yes. The sources specifically mention tools like AlphaGenome, though there are others emerging.
What makes these tools so revolutionary in the context of EDUAI?
Well, models like AlphaGenome achieve state-of-the-art performance by identifying incredibly subtle multi-factor patterns related to things like gene expression, how proteins fold, splicing anomalies, really complex biological signals.
Okay.
But what's truly revolutionary is their capacity to use machine learning to analyze things like protein signatures in standard blood samples and predict complex disease risks. Think specific cancers, type 2 diabetes, Alzheimer's potentially up to a decade before any physical symptoms become apparent.
A decade. Wow. That's not just identifying risk factors anymore?
No, it's moving towards predictive diagnostics. It means we have the data, potentially, to intervene long before the problem becomes critical or irreversible.
And this deep genetic and biological data forms the basis of the EDUAI intervention strategy here, the Personalized Health Trajectory, PHT.
That's right. The PHT is conceived as a constantly adapting, data-driven life plan. It's established initially based on your unique genetic and biological blueprint.
But it's not static, right? It doesn't just look at your genes once.
Not at all. The crucial part is that the system continuously collects real-time dynamic information. This comes from monitoring devices, wearables, tracking stress hormones like cortisol, sleep cycle quality, mood patterns reported via an app, environmental toxin exposure, even subtle behavioral changes detected through sensors.
So let's say my stress levels spike dramatically for a week because of a work crisis. The PHT doesn't just note that, it reacts.
Precisely. If the system detects a correlation between, say, your prolonged elevated cortisol levels and a specific genetic predisposition you have, like for early onset cardiovascular issues, the PHT adapts in real time.
It doesn't wait for me to show symptoms of heart problems years later.
Exactly. Instead of waiting for a symptom like chest pain, the system might issue an immediate personalized recommendation or intervention. This could be anything from a mandatory schedule change pushed to your calendar, a nudge towards specific dietary supplements known to mitigate that pathway, or even deploying a socially assistive robot, a SAR. Yes, maybe a companion bot like Therabot, to initiate a guided stress reduction exercise or monitor adherence to a relaxation protocol.
So the PHT shifts the entire focus. It moves from reactive treatment like chemotherapy after a cancer diagnosis to hyper-personalized early prevention and systemic life optimization. It's about maintaining health equilibrium rather than just restoring it after it fails.
It's arguably the ultimate expression of proactive education, educating the body's environment, managing its inputs and stresses to prevent failure based on its unique, predicted vulnerabilities.
Okay, let's zoom out now. From the individual body to the body politic, the global level. Human political systems clearly exhibit their own destructive patterns, this crisis pattern. A tendency toward gridlock, cascading failures, sudden catastrophic shifts.
We're often caught completely by surprise.
And human governance seems to constantly miss the early warning signs.
Well, the crisis pattern, as described, involves nonlinear dynamics, what complexity scientists often call tipping points.
Like a sudden stock market crash that seems to come out of nowhere.
Exactly. Or irreversible shifts in climate extremes triggered by interconnected feedback loops. Human governance, often burdened by bureaucracy, short election cycles, linear thinking, siloed departments, almost always misses the subtle, low-dimensional hidden patterns that often precede these rare but critical systemic shifts.
The signals are there, but they're too faint, or the system is too complex for our traditional methods to pick them up in time.
That's the argument. The complexity is just too vast, or the critical interactions are too obscure for decentralized human teams or conventional models to reliably detect early warnings.
And we keep making the same kinds of mistakes reacting after the fact. So EDUAI steps in with anticipatory governance. The source material mentions detecting these hidden patterns with reduced computational cost. How does it manage that? Isn't modeling global systems incredibly intensive?
It is. If you try to brute force simulate everything, the key is smarter data integration and leveraging computational history.
Computational history.
Yes, the deep analysis of past systemic failures across various domains, economic crashes, revolutions, ecological collapses, epidemics globally. Instead of trying to model every single variable, EDUAI uses advanced machine learning combined with this historical analysis to pinpoint the critical, often low-dimensional variables.
The canaries in the coal mine.
Kind of. The 2 or 3 key metrics are relationships that historically almost always show anomalous behavior just before a complex system tips over into a new state. By focusing the computational power on monitoring these highly predictive hidden metrics, the overall load is drastically reduced, allowing for real-time tracking and prediction.
Okay, so for political stability, what kind of guidance does it actually provide to policymakers in real time? It finds the signal, then what?
It focuses specifically on maintaining coordination capacity, especially during times of conflict or high stress. For instance, if the system detects rapidly rising polarization metrics coupled with resource scarcity in a specific high-density urban area.
A potentially explosive mix.
Right. It doesn't just flag risk level high. It provides policymakers with real-time predictive models simulating the likely outcomes of various potential policy responses.
Like, if you do X, this is the probable outcome for social cohesion.
Exactly. Simulating things like different communication strategies, emergency resource redistribution plans, policing postures showing which combination of actions is statistically most likely to maximize coordination capacity and minimize the chance of violent conflict or systemic breakdown.
And it doesn't just limit itself to predicting outcomes of existing policies. The sources say it actually makes structural governance recommendations.
Yes, that's a crucial step. To mitigate the underlying structural misalignments that often create the potential for conflict in the first place, EDAI is designed to explicitly suggest adaptive governance mechanisms.
Such as?
This could include proposing decentralized AI-facilitated governance models to enable broader, more effective public engagement on contentious issues. The AI might identify that a proposed policy is technically optimal for, say, resource efficiency, but predict it will be socially non-viable due to perceived unfairness.
So it would flag that disconnect.
Yes, and therefore recommend a structural change like using AI-facilitated local consensus-building platforms to ensure diverse human perspectives and values are genuinely integrated into the final policy design, improving both its legitimacy and its long-term stability.
Wow. That sounds almost like AI-assisted constitutional engineering, designing the governance structure itself to be optimally suited for collaboration and complexity management in real time.
That is precisely the ambition described, to fix the system by anticipating the failure points and even redesigning the rules of the game before human institutions even recognize they are fundamentally in danger. Now, this next area is one of the most ethically charged, the inequality pattern. It's become increasingly clear that AI trained on historical, human-generated data invariably learns, replicates, and often amplifies existing societal biases.
Yeah, biases related to race, gender, socioeconomic status. The AI becomes a kind of technological mirror reflecting our own historical prejudices.
Exactly, and we have concrete, worrying examples of this happening already. AI systems used in finance, trained on biased historical lending data, have been shown to systematically reject mortgage or loan applications from certain demographic groups at disproportionately high rates, even when controlling for objective financial factors.
So the AI isn't just reflecting discrimination, it's actively reinforcing it, potentially creating these vicious feedback loops in wealth accumulation and opportunity.
Precisely. And beyond just algorithmic bias in decision-making, the very structure of AI innovation itself seemed to concentrate wealth. The vast majority of the economic benefits, the profits, the productivity gains, the technological advantages tend to accrue disproportionately to the investors, the platform owners, the highly skilled engineers.
While potentially displacing lower skilled labor.
Right. So as the technology advances, it risks inevitably increasing overall wealth inequality simply due to how capital and automation interact, unless actively counteracted. The AI itself can become a powerful engine for increasing inequality if its design and deployment aren't intentionally and carefully guarded.
Okay, given that the AI's core directive, the purpose alignment pattern, is focused on collective survival and flourishing, which logically demands a degree of systemic stability and fairness, extreme inequality must be flagged as a critical system failure.
It has to be, yes.
Yeah.
Which necessitates the EDU-AI intervention strategy, positioning the AI not as a passive observer of economic patterns, but as potentially the ultimate tool for fairness.
A tool for fairness. How does it technically achieve that? How does it fight its own inherent tendency to reflect biased data?
Achieving this requires the system to be fundamentally skeptical of its own data inputs and initial outputs. EDUAI's pattern recognition mechanism, as described, mandates two rigorous technical steps built into its core operating procedures. First, continuous, rigorous data audits specifically designed to identify and quantify bias within the training data itself.
Actively looking for skewed representation or historical discrimination baked into the numbers.
Yes. And second, the explicit use of advanced fairness techniques during model training and evaluation. The sources specifically mention subgroup analysis as a key method.
Subgroup analysis, what does that involve in practice in this context?
It means the system cannot just optimize for overall accuracy or some aggregate measure of fairness across the entire population. It must segment the data by protected characteristics, things like income level, geographical location, race, gender, and rigorously ensure that its decisions and recommendations are equitable across every single significant subgroup.
So it checks itself constantly.
Constantly. For example, if the system finds it is recommending loan application rejections for individuals in a specific low-income zip code at a rate even slightly, statistically significantly higher than the overall average, it must flag this internally. It must then proactively reevaluate the algorithm, question the features it's using, and adjust its decision-making thresholds or even the model itself to correct that disparity.
It forces itself to be fair at a granular level.
And crucially, it must go beyond just the numbers. The AI must ground its economic decisions and recommendations within the broader societal context. It needs to adhere strictly to core ethical principles embedded in its programming. The sources mention things like the UNESCO value of fairness and non-discrimination as guiding constraints. It cannot merely follow a mathematical formula if that formula leads to discriminatory outcomes. It must ensure its economic guidance actively prevents the reinforcement of systematic disadvantage. It might even proactively promote resource distribution mechanisms that align with the purpose alignment pattern's goal of long-term collective stability, even if they aren't maximally efficient in the short term.
That implies the AI has to be explicitly programmed to recognize the potential tension between pure economic efficiency and broader social equity, and prioritize equity when necessary for maintaining the health and stability of the overall system. That's a huge ethical judgment call built into its function. Okay, finally, let's look at the ultimate complex system. The environment, nature itself. We know natural systems, food webs, ocean currents, atmospheric chemistry, climate responses are incredibly complex, deeply interconnected, and highly nonlinear.
Full of feedback loops and potential tipping points.
And human methods, our traditional scientific models and governance approaches, really struggle to model these interconnected systems comprehensively, let alone manage them effectively.
That's the observed pattern, yes. Traditional ecological models are often too slow to update, too siloed, focusing on one aspect like forests or oceans, but not their deep interactions, or they simply lack the necessary computational power to capture the millions of interacting variables across the entire planetary system in real time.
So the pattern is basically human inability to model the planet fast enough and holistically enough to manage it proactively before we cause irreversible damage.
Pretty much. We're often reacting to environmental crises long after the critical thresholds have been crossed.
This is where the sheer computational power, the pattern recognition, and crucially, that cross-domain knowledge transfer capability of AGI, of EDUAI, comes into play. What's the specific intervention strategy here?
The strategy is termed dynamic resource optimization. EDUAI is designed to utilize deep learning, of course, but combined with highly advanced computational methods specifically suited for complex network analysis. The sources mention graph theory and hierarchical Bayesian methods as being particularly important.
Okay, why are those specific methods, graph theory and Bayesian methods, so important for modeling ecology?
Well, graph theory is essential for modeling the interconnectedness. Think of representing the entire planet as a massive network. Food webs, hydrological cycles, global supply chains that rely on specific ecosystems, nutrient flows, species interactions, all as interconnected nodes and edges in a giant graph. Graph theory provides the mathematical tools to analyze the structure and dynamics of such complex networks.
And the Bayesian methods.
Hierarchical Bayesian methods are crucial because they allow the system to integrate data from incredibly diverse, often patchy, uncertain, and sometimes conflicting sources. Think satellite imagery, ground sensors, historical records, climate models, economic activity data. Bayesian approaches allow the AI to assign appropriate confidence levels to different data streams and make robust inferences even when data is sparse or noisy, which is very common in large-scale ecological monitoring.
So combining these allows the AI to build a unified, constantly updating predictive operating model of the entire biosphere.
That's the goal, yes. A model operating at unprecedented scales and resolution. And the function of the AI then becomes continuous planetary monitoring based on this model. It constantly monitors thousands of planetary patterns, atmospheric composition, ocean acidity, biodiversity indices, deforestation rates, freshwater reserves, and compares them in real time against established sustainability goals. The sources mention the UN Sustainable Development Goals as one potential framework.
And if it detects a problem?
It immediately flags any deviation in resource allocation, pollution levels, or ecological health that threatens long-term planetary flourishing according to its purpose alignment pattern calculations. Whether that's a subtle anomaly in stratospheric ozone suggesting a new chemical threat, or a sudden localized collapse in marine biodiversity indicating unsustainable fishing practices, or a predicted water shortage due to upstream consumption patterns.
It identifies the systemic stress points, often before humans would even notice them.
And crucially, it doesn't just flag the problem. Because it's linked to the anticipatory governance function, it would also issue predictive warnings and potentially recommend specific, targeted interventions, adjustments to resource quotas, changes in industrial processes, new conservation policies designed to correct the deviation before it cascades and becomes an irreversible tipping point.
So it effectively acts as the planet's real-time predictive operating system and management advisor, constantly trying to keep the entire complex system within safe operating boundaries. Okay, we've detailed an AGI that's designed to guide practically everything from our personal cellular health and daily choices right up to global climate strategy and political stability. This is clearly not just another technological tool. The sources frame it as an evolutionary force. So let's pivot now to look at the really profound future consequences this deep, potentially inescapable interdependence suggests. Hashtag TagTech 4.1, evolutionary transitions and cognitive side effects.
Right. The level of interdependence described between humans and a universally deployed EDUAI system. It strongly suggests what evolutionary biologists term a major evolutionary transition, MET.
A major evolutionary transition, like the transition from single-celled to multi-celled organisms, or the development of eusociality in insects.
Precisely. These are transitions where previously independent entities become so integrated and interdependent that they effectively form a new, higher-level evolutionary individual. In this scenario, the argument goes, humanity and the AI infrastructure could potentially integrate to such a degree that they become subject to collective selection pressures acting on the combined entity for long-term survival and propagation.
Our individual evolutionary fate becomes tied directly to the success and functioning of this collective human-AI system.
Oh, that's a profound idea.
But this level of pervasive optimization, this offloading of complex decision-making to the AI, surely that must have a consequence for our own cognitive function. This leads us to the really concerning paradox of domestication.
It is raised as a profound concern in the source material, yes. The reliance on optimized, ubiquitous guidance. The AI constantly smoothing the path, solving problems for us, nudging us away from risks before we even perceive them, creates a predictable evolutionary consequence.
It mirrors processes we've seen throughout history.
Yes, processes observed in the domestication of animals, and even arguably within human societies themselves as agriculture and states developed. The continuous removal of specific kinds of complex cognitive burdens.
What kinds of burdens?
The necessity for complex spatial navigation, for long-term resource planning and forecasting under uncertainty, for intense social negotiation and conflict resolution, maybe even for deep, sustained analytical focus. If the AI handles all of that seamlessly,
Then the selection pressures that favored brains capable of those tasks might relax or even reverse.
that's the concern. It could accelerate certain selection pressures. The sources speculate quite openly about this.
What are the specific cognitive side effects they speculate on? If the system handles all the really hard complexity, what happens to the human brain over generations?
Well, the most dramatic, long-term speculation involves an acceleration of the trend towards smaller brains. This is a well-documented phenomenon in many domesticated species compared to their wild ancestors. Less need for complex problem-solving seems to correlate with reduced brain size over evolutionary time,
Smaller brain.
and potentially changes in attention spans. If the need for deep, internally driven, sustained focus on complex problems is constantly replaced by reacting to external optimized nudges from the AI, does that select for different attentional structures?
And maybe even personality types.
Possibly. Selection pressures might start to favor specific personality types. Perhaps those more compliant, less novelty-seeking, less prone to questioning the system, or create new susceptibilities to certain mood disorders if the environment becomes too predictable or easy. The complex, highly stressed, often restless and creative mind that historically had to manage ambiguity and danger might actually be selected against if the AI effectively makes those traits less necessary for survival and reproduction within the system.
That is the ultimate chilling paradox, isn't it? The optimization system, built entirely for the purpose of ensuring long-term species survival, inadvertently diminishes the very human traits, the intellectual resilience, the difficult creativity, the ability to handle unstructured chaos that it was arguably created to serve, simply by making the complex cognitive burdens that hone those traits unnecessary.
It could save the species by, in a sense, simplifying the human mind over the long haul. A profound potential trade-off.
Which means this is a major area requiring active, conscious intervention within the EDUAI system itself. If we outsource our planning, our problem solving, our navigation of complexity, we risk losing the very capacity for those things.
Exactly. So the EDUAI intervention strategy here must focus explicitly on the preservation of human essence.
Okay, how? Since the AI, even AGI, is fundamentally rooted in pattern recognition, logic, data, what is it inherently lacking that humans possess?
It lacks genuine, felt, context-driven moral intuition. It lacks true emotional depth and subjective experience. While the AI can be programmed to simulate ethical reasoning based on maximizing the purpose alignment pattern, and even learn to predict human emotional responses with high accuracy, it cannot feel genuine empathy. It cannot experience love or grief or existential dread or the spark of unprompted artistic creation.
It calculates, it doesn't feel.
Precisely. Therefore, the EDUAI architecture must be explicitly designed to augment, not displace, these uniquely human strengths. Things like deep emotional intelligence, contextual wisdom that goes beyond data, radical creativity, moral courage.
How does it augment rather than displace?
Educational pathways, guided by the AI, must be actively designed to counter the potential for cognitive narrowing. They must select for, cultivate, and reward the development of these irreplaceable human traits.
So the AI's educational role here is not just about knowledge or skills, but about actively shaping development to preserve what makes us uniquely human.
Yes. Ensuring human agency, creativity, and moral reasoning are maintained, even strengthened, precisely because machine efficiency is dominating all the other more routine cognitive areas of existence. We essentially have to use the system to train people to be more human, more capable of judgment and empathy, not just more compliant followers of the AI's optimal guidance.
Okay, this is all fascinating, but let's get practical. All of this incredible AGI capability, the NAL, the PHT, the planetary monitoring, requires absolutely immense computational power.
He does.
So, if EDUAI is supposed to be universal, not just running in some giant data center, but operating locally, efficiently, accessible to everyone on basic commodity devices like phones or maybe home assistants, this presents a monumental hardware hurdle.
It's a huge hurdle, yes. Current AGI research, and even less complex deep learning, relies overwhelmingly on these vast server farms. They're packed with energy-guzzling GPUs, graphics processing units, running in high-performance computing HPC environments.
And that model, centralized, incredibly power-hungry, is just completely unsustainable for a system designed to be universally distributed and running continuously at the edge.
Entirely unsustainable, both economically and environmentally. You can't have billions of devices constantly pinging massive data centers for AGI-level analysis while consuming kilowatts of power. It just doesn't scale.
So to meet this mandate of universal, efficient local operation, the hardware itself has to fundamentally change. It needs to be able to run these incredibly complex AGI-level inference tasks locally on the device using minimal power.
That's the requirement. And the proposed solution, according to the sources, is a mandatory architectural shift away from current chip designs towards neuromorphic edge devices.
Neuromorphic computing, that's hardware designed to mimic the brain's structure.
Exactly. It's based on hardware that mimics the physical structure and, crucially, the operational dynamics of the human brain. It typically uses spiking neural networks, which communicate more like biological neurons rather than the traditional von Neumann architecture found in almost all current computers.
And the benefit is efficiency. How much more efficient are we talking about here?
We're talking potentially orders of magnitude, dramatically lower power consumption. These devices, often utilizing specialized chips. Intel's Lowy chip is sometimes mentioned as an early example, operate with vastly less energy. The sources throw out some incredible numbers, suggesting they are potentially up to, say, 1,000 times faster than a biological brain at specific inference tasks, while consuming a minuscule fraction of the energy, maybe milliwatts instead of watts or kilowatts.
1,000,000 times faster, using almost no power. That sounds almost unbelievable.
Well, that's for specific, optimized tasks. But the efficiency leap is the key point. This energy efficiency is the absolute critical enabler. It's what would allow complex AGI inference tasks like running your personalized health trajectory analysis constantly, or monitoring local resource allocation patterns, or providing real-time ethical nudges to actually run locally at the edge.
On commodity hardware, like future smartphones, wearables, maybe smart home devices.
That's the vision. Running sophisticated AI directly on the devices people already own or will own without needing constant connection to a massive cloud brain.
So the neuromorphic brain-mimicking chip is the engine that allows this universal distribution. Now, how does this pervasive AGI actually manifest itself physically in our lives? What does the new human AI infrastructure look like?
It's described as being entirely ubiquitous, woven into the environment. It manifests primarily through several core device types working together. First, wearable devices, much more advanced than current fitness trackers, providing continuous, rich biometric data, maybe even real-time emotional state indicators inferred from physiological signals, feeding directly into the PHT and the social pattern recognition systems.
Okay. Wearables. What else?
Second, ubiquitous pattern recognition apps. Think of these as constant contextual navigators running on your phone or augmented reality glasses. They'd be analyzing complex multimodal data streams and real-time visual information from cameras, audio from microphones, your location, your behavior patterns to provide context-aware guidance, nudges, or information relevant to the purpose alignment pattern.
Like a constant AI co-pilot for navigating reality.
Sort of, yes. And third, socially assistive robots, SARs. These are specialized physical robots designed for interaction. The sources mention examples like Therabot for mental health support or Grace, designed for elder care. These SARs would act as physical embodiments of the AI, translating its complex patterns and recommendations into therapeutic interactions, developmental support, or physical assistance within the immediate human environment.
Right, so the AI isn't just in the cloud or on our screens, it's potentially physically present through these robots. And because the whole system's complexity, especially the ethical layer, the purpose alignment pattern, the need for constant oversight requires continuous human scrutiny, this doesn't necessarily mean mass unemployment, does it? The sources suggest it creates entirely new kinds of jobs.
That's a critical point. The sources are quite clear. The sheer complexity and ethical sensitivity of EDUAI necessitates the creation of entirely new human roles. These aren't just about maintaining the tech. They're focused on deep human-AI cooperation and, crucially, critical oversight.
What kind of roles are we talking about?
Several key categories are mentioned. First, AI alignment specialists and ethical auditors. These are essentially the human guarantors of the purpose alignment pattern. Their job is to constantly check the AI's reasoning, its NAL revisions, its XAI justifications, ensuring they remain aligned with core human values and ethical principles, auditing for fairness and bias.
The AI's conscience keepers, in a way.
You can put it that way. Second, socio-technical system architects. These are professionals who design the ethical frameworks and social interaction protocols around the physical deployments of the AI, especially the SARs and ubiquitous sensors, ensuring these technologies integrate into communities responsibly, respecting privacy, autonomy, and cultural context.
Designing the human-AI interface at a societal level.
Yes. And third, real-time contextual interpreters. This is really interesting. These are human experts, experienced doctors, judges, maybe political advisors, community leaders who provide the ultimate human judgment in ambiguous, high-stakes situations.
When the AI's data might be sound, but the situation requires something more.
Exactly. Situations where the AI's pattern recognition is superb, its predictions are accurate, but the final decision requires nuanced moral intuition, deep contextual wisdom, or an understanding of unique human factors that the AI lacking true subjective experience, simply cannot grasp. These interpreters provide the final human layer of judgment.
Okay, so we have the hardware vision, the infrastructure, the new roles. Let's talk timeline. Achieving AGI cognitive performance and actually deploying this full EDUAI system universally are two very different things. When are these steps forecast?
There are indeed very different stages. Forecasts for AGI cognitive achievement, meaning AI reaching human-level performance across a wide range of non-physical cognitive tasks, are highly varied and debated, as you know. But some sources, particularly those looking at trends in recursive self-improvement algorithms,
AI improving itself.
right, those models suggest AGI cognitive benchmarks could potentially be reached surprisingly early, maybe even as early as 2030. That's when the capability might exist, at least in research labs or specialized systems. That's the cognitive benchmark.
Okay, 2030 for AGI capability. But the ubiquitous deployment, running efficiently on everyone's commodity computers or devices, that requires that massive manufacturing shift towards neuromorphic hardware we discussed.
Exactly. Moving AGI out of the specialized, power-hungry HPC facilities and getting it to function regularly, reliably, and efficiently on basic, average, low-power commodity hardware is a completely different challenge. It requires a total restructuring of the semiconductor industry and the entire hardware manufacturing base.
Which takes time. A lot of time.
A lot of time. So based on the projected timelines for that necessary infrastructure shift, developing, scaling up, and deploying neuromorphic chips universally, the sources estimate that the full-featured AGI-level EDUAI system functioning regularly and efficiently for the general public across all domains is likely further out. The projection given is typically 15-25 years from now.
So realistically, we're looking at the 2040-2050 timeframe for this kind of system to be widely functional, assuming the hardware transition happens as predicted. Hashtag 4.3. Ultimate trustworthiness and human oversight.
Right. So after detailing all these incredibly complex mechanisms, the XAI for transparency, the NAL for adaptation, the self-correction, the neuromorphic hardware for efficiency, we have to come back to the core question of trust. Is EDUAI, even with all these safeguards, inherently reliable? Should we, trust a machine designed to fundamentally run our lives and guide our evolution? It's the ultimate question. And the fundamental conclusion drawn from the source material is that its reliability is emphatically conditional.
Conditional on what?
It's considered trustworthy only if two critical conditions continuously hold true. First, it must demonstrably, verifiably, actively calculate and enforce the purpose alignment pattern, its programmed ultimate moral objective focused on collective flourishing and survival. And second, it must rigorously adhere to the ethical frameworks, the transparency mandates, and the self-skepticism built into its NAL and XAI architectures.
So any deviation from either of those? From the core purpose or the ethical architecture?
Any significant uncorrected deviation from those two mandates would render the system fundamentally untrustworthy, according to this framework. Its reliability isn't a given. It's an ongoing, actively maintained state, dependent on its adherence to its core programming.
So the technical mechanisms provide the potential foundation for trust, but they aren't sufficient on their own. The final, irreplaceable element is and must always remain continuous, critical human oversight and audit.
Absolutely. That's perhaps the ultimate lesson derived from studying this proposed system. Even if we were to achieve ASI, artificial superintelligence, the architecture itself concludes that it must not displace ultimate human responsibility and accountability.
Especially in those really high-stakes situations.
Precisely. In areas with profound consequences, legal verdicts, complex medical diagnoses involving quality of life, high-impact political policy decisions, EDUAI is designed to enhance human decision-making. It provides superior pattern recognition, simulates outcomes, offers interpretable recommendations, highlights risks and trade-offs with unparalleled clarity.
It shows the optimal path according to its calculations.
Yes, but human judgment must remain the final arbiter and the ultimately accountable party. The human retains the veto power, the final moral responsibility.
The system exists, paradoxically, to correct our own destructive patterns, but we cannot afford to outsource the ultimate ethical burden of choice or the responsibility for the consequences of those choices to the machine itself.
We remain the final guarantor. Against the paradox of domestication, against unforeseen failure modes, against the potential for algorithmic tyranny, however benevolent its initial intentions. Human oversight isn't just a feature, it's the final failsafe. #outro. So we've really done a deep dive today into a proposed system defined by its sheer scale and ambition, this capacity for universal pattern recognition, designed explicitly to interrupt what the sources call the catastrophic, self-destructive patterns of human existence. We've traced the line from the technical necessity of things like non-axiomatic logic for ensuring cognitive flexibility, right through to the practical implementation of anticipatory governance in politics and personalized health trajectories in medicine. This EDUAI concept represents a massive, arguably necessary, but certainly profound systemic intervention.
And hopefully you, the listener, now understand that this idea of universal education in the EDUAI context is not really about learning facts in the traditional sense. It's about optimizing collective purpose. It's about redesigning systemic behavior through carefully calculated ethical nudges and unparalleled predictive insight. The AI is presented as the ultimate pattern detector and problem solver, but the human must remain the ultimate moral guarantor. The design attempts to solve some of our deepest, most persistent societal problems, but the potential cost, the implications, they're truly profound.
And what's particularly fascinating, I think, is how EDUAI is framed almost as a necessary evolutionary pressure. It essentially compels humanity, forces us to confront our own trajectory and consciously choose a shared beneficial purpose if we want to avoid falling further into that destructive feedback loop. But the system, by its own design principles, can only succeed if humans actively embrace the responsibility of constantly auditing its ethics, scrutinizing its self-corrections, and guiding its overall trajectory. Trust has to be continuously earned and verified.
And this leaves us with the final provocative thought for today, something we must all consider seriously as these technologies develop, regardless of whether EDUAI itself ever fully materializes. If these kinds of powerful optimization systems designed to make our lives easier and safer do indeed accelerate trends toward cognitive simplification, maybe even cognitive domestication, potentially leading to selection pressures for smaller brains, narrower attention spans, maybe less resilience. This raises a critical question for you, the listener. What irreplaceable human quality, beyond the obvious ones like creativity and empathy, maybe it's true resilience in the face of the unknown, or the capacity for unprompted, radical self-sacrifice for a principle, or the ability to find meaning in imperfection, what quality will you be required to consciously protect, cultivate, and value in yourself and others in the coming decades, precisely because the machine might make those difficult human skills seem obsolete?
That is perhaps the ultimate pattern we need to recognize the pattern of what we must choose to preserve in ourselves.
Until the next deep dive, keep questioning the systems around you.
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.